Good day. Welcome to software testing class. We'll start module 3, which is structural testing. This is the agenda of the session. First, we'll focus on what is structural testing. We'll see what are the statement testing is all about. Then we'll see what is branch testing and condition testing, path testing, which is basically depends on the DD paths. Then we'll see test coverage metrics. We'll see basis path testing. Then we'll see data flow testing, which uses define use properties for DU testing. We'll see what is slice based testing, test execution, scaffolding, test variables, capture and replay. Then we'll conclude the class. So the entire module 3 is divided into 3 sessions. Session 1 is introduction to structural testing. Basically, we focus on all fundamentals concepts needed for structural testing. Session 2 talks about basis path testing and data flow testing, which are both are important from the point of examination as well as from the point of laboratory exercises. Session 3 focuses on slice based testing and test execution, scaffolding and all the other stuff. Now we'll focus on session 1, which is introduction to structural testing. You all know that the software testing has two components, has two methods of testing. One is functional, the other is structural. Structural testing focus is also called as white box testing, where we consider every line of the code into account while testing our application. From the laboratory point of view, basis path testing. In the lab, we have exercise number 10, 11 and 12. If you see this, 10, 11 and 12. Data flow testing, the exercise number 11. So these 4 experiments falls under structural testing, which is again white box testing, where completely this is done by a developer during the software development life cycle. So in order to understand structural testing, there are certain important definitions or important concepts where everybody should understand. First, let's focus on some of the basic fundamental concepts, like what is graph. You all know that graph is a collection of vertices and edges. There might be different types of graphs. One is directed graph, undirected graph, acyclic or cyclic graph. In degree and out degree, if an edge if edge is moving towards vertex, we call it as in degree. If any edge going out of the vertex, we call it as out degree. Let's consider a small example here, a graph of 5 nodes. For the node, you consider for the node 3, where we have 3 in degree and 0 out degree. So I'm talking about this circled node where we have in degree. So there are 3 edges coming into one vertex or node. So nothing is going out from this node. So this we call it as in degree and out degree. So with this, now let's move on to the next slide, which talks about program flow graph. Program flow graph is the graphical representation of a program using graph, starting from first node to the last node, or from the first line to the last line. So this is very important, from the first line to the last line. So the graphical representation of a program using graph from the first line to the last line. This technique is used for path testing, because without deriving the program flow graph, you cannot do the path testing. So let's consider an example. Given a program written in imperative programming language, its program flow graph is a directed graph in which nodes n are either entire statement or fragments of statements, and edges represents flow of control. So any program written in any imperative language, the program flow graph will be a directed graph which is represented using nodes and edges. Nodes represents the small statements program statements are fragments of statements. Edges represents flow of control. It is the movement of execution from one line to another line. So with this, now let's try to understand what are the statement fragments examples. So begin and end, for loop, while loop, simple if, nested if, case, or any programming constructs will fall under this statement fragments. It might be linear or nested or knotted, so or case. So any program, any control structures, any program segment falls under this. Either it might be simple or complex. We call it as statement fragments. Statement fragments. The importance of the program flow graph is that program execution corresponds to the path from the source to the sink node, from the line number 1 to the line number end. The program flow graph should complete from line number 1 to the line number n. So we should have a single entry and a single exit while executing the program. Test cases are run to find the program path from source to sink. So if you find out number of paths, so we are going to run the test cases to find the paths, valid paths from source to sink. Now let us try to understand flow graph notations. So we are using different variety of notations. Few of them we'll see. This is sequence. So where line by line, we'll have sequence of statements in a program. This is how we are going to represent using flow graph notations. So this is if then else. Suppose if this is become true, then we are taking this path. If this is false, we are taking this path. So this is an if then else flow graph notations. This is only if then. Suppose we have only one path. Suppose if this is true, coming like this. If it is false, coming like this. So this is if then. So this is case. Suppose if any of this is true, then it will go to the line number 1. If it is true, line number 2. If it is true, line number 3, and then so on. So based on the case, it goes to a particular fragment program segment to execute. So these are all some of the flow graph notations. We have for loop. So once for loop is always called as pre-test loop. It checks at the entry for the condition, then it will get into the program segments. Then we have post-test loop where the condition will be tested at the end. In the for loop, the condition is tested in the beginning. In the while loop, the condition is tested at the end to get into the execution. So these are all certain flow graph notations we are using. One is sequence, if then else, if then, case, pre-test loop, and post-test loop. This is the program flow graph for a given triangle problem statement where we have line number 1 to line number 23, which is the program written to evaluate a given triangle is a we can form a triangle, or triangle is of form of equilateral triangle, or scalene triangle, or isosceles triangle. In line number 1 is starting where we have commented this program triangle, and line number 23 is sink where it's end triangle. Line number 2, which is we have defined 3 variables of type integer, and we have defined a boolean variable of type is a triangle. So output, enter 3 sides of a triangle. We are prompting the user to enter the 3 sides of a triangle, where is entering input a comma b comma c. Then we are trying to display all these 3 sides. Then we are checking a is less than, one side should be less than or equal to b plus c, and b is less than or equal to a plus c, and c is less than or equal to a plus b. If this becomes true, then we can form a triangle, or else we cannot form a triangle. If we can form a triangle, then triangle is of equilateral triangle, or whether it cannot be formed a triangle, or it can be scalene, or it can be isosceles. Now for the same program, we have written the program flow graph. What I request all of you is to analyze the line numbers. Line number 4, 5, 6, 7, 8 up to line number 3 we are not considered. From line number 4, 5, 6, 7, where which is a sequence, so line number 9, which is called as if statement, if you see this if statement, if it is true, then line number 10 we can form a triangle. If it is false, we cannot form a triangle. Again, end if. So this is end if. Now suppose if we can form a triangle, line number 13, if we can form a triangle, then we are getting into nested if, where we are checking different conditions, whether we can form equilateral triangle, or we can form scalene triangle, or we can form isosceles triangle, or we cannot form triangle at all. Then we are trying to end the program at line number 23. Then we'll see for the same program flow graph there are certain observations we have made. Line number, node number 4 to 8 are a sequence. There is no branching at all. Node number 9 and 12 are if then else construct. Node number 13 and 22 are nested if then else construct. Node number 4 and 23 are the program source and sink nodes, single entry and single exit. There are no loops, so this is a directed acyclic graph. There are no loops, so this is called as directed acyclic graphs. Now we'll see these are all some of the observations which anybody wanted to note it out from the program flow graph. Nodes up to 4 to 8 is sequence, 9 to 12 if then else, then 13 to 22 are nested if then else, then 4 and 13 are source and sink, which is single entry and single exit. Since there are no loops, so it is called as directed acyclic graph. Now we'll see decision to decision path. So this is very important, decision to decision. The best known form of structural testing is based on decision to decision path. A DD path is a sequence of statements that begins with the out degree of a decision statement and ends with the in degree of the next decision statement. There are no internal branches in such a sequence like a row of dominoes. We will define paths in terms of nodes in a directed graph where path is equal to chains. We will define paths in terms of nodes in a directed graph where paths is equal to chains. So here two important terminologies are very important, my dear students. One is in degree and out degree, out way and in way. Now let's try to understand what is chain. Chain is a path in which the initial and terminal nodes are distinct. What is chain? A path in which the initial and terminal nodes are distinct. Every interior node has in degree is equal to 1 and out degree is equal to 1. In degree is equal to 1 and out degree is equal to 1. What is in degree? A vertex, a edge will have, one vertex will have one edge coming in. So that is called as in degree. If one edge is going out from that vertex, then we call it as in degree is equal to 1 and out degree is equal to 1. So a chain can consist of only one node and no edges. Length of chain is the number of edges. Every statement in a program is a member of one and only one DD path. This is very, very important. Every statement in a program is a member of one and only one DD path. The objective is to scan the entire program to break it into number of unique DD paths and use each of those paths as a node to build a DD path graph. So DD path graph is nothing but a condensed graph which is derived from the program flow graph. So I'll just write a small, so this is a node. So if where in degree is equal to 1 and out degree is equal to 1. So one edge is coming to this, one edge is going out of this vertex or node. So this is called as in degree is equal to 1 and out degree is equal to 1. What is the objective of this? Objective is to scan all unique DD paths starting from the initial node to the sink node, starting node to the ending node. Now with this basic background of DD paths, now let us move on to how what is the initial and terminal node looks like and all that. So this is initial node where out way of decision statement, and terminal node in way of the next decision statement. Between all these things we call it as interior nodes. The chain of a node in a directed graph of length is equal to 4. The length of the chain is equal to number of edges. The length of the chain is equal to number of edges. So again we all know that in this, what is the chain? The length of the chain is equal to number of edges. How many edges are there? So 1, 2, 3, then here 4. So the length is equal to the 4. The length of the chain is equal to number of edges in a given program flow graph, starting from the initial node to the terminal node. Let's try to understand the definition of DD path. DD path can be defined as sequence of nodes in a program graph such that these 5 cases should follow. Case number 1, it consists of a single node with integer is equal to 0. This is the source node where we will not have anything coming into the node. So integer is equal to 0. Case 2, it consists of a single node without degree is equal to 0, which is the final DD path, which is the sink node, where we don't have anything to go out from the last node or sink node. Case number 3, it consisting of a single node with in degree is greater than or equal to 2 or out degree is greater than or equal to 2. Assures that no node is contained in more than one DD path. Case number 4, it consisting of a single node with in degree is equal to 1 and out degree is equal to 1, needed for short branches. This is needed for short branches. Case number 5, it is a maximal chain of length greater than or equal to 1. Normal case, single entry and single exit sequence of nodes. So this is the formal definition of a DD path. You should follow any one of these cases. So what is that? DD path is a sequence of nodes in a program graph such that case 1, case 2, case 3, case 1, case 2, case 3, case 4, case 5. What is case 1? It consisting of a single node with in degree is equal to 0. It consisting of single node without degree is equal to 0. It consisting of single node with in degree is greater than or equal to 2 and or out degree is greater than or equal to 2. So it contains a single node with in degree is equal to 1 and out degree is equal to 1. So this is needed for short branches. It is a maximal chain of length greater than or equal to 1. So normal case, single entry and single exit sequence of nodes. So this is the classical definition of DD path. DD path. Now there is a path from node Ni to Nj and not the reverse direction, because it's a directed graph. Because it should be a directed graph, because the line from line number n, line number 1 to line number 23. If you consider our triangle problem statement, the line number 1 to line number 23, that's how the node should go. It's not in the reverse direction. Now let's go in depth about program graph and DD paths. So this is program written for a triangle problem. This is the program flow graph, control flow graph or program flow graph which you have written. Now for this we wanted to arrive the DD path. So we have written, we have told the definition of DD path, which is having 5 cases. The 5 cases are here. Case number 1, case number 2, case number 3, case number 4 and case number 5. For all the cases we have written DD paths with the specific case of definitions. So now I will try to explain one or the other. So program flow graph node 4, it is first. Here it is case number 1, because in degree is equal to 0. So node 5 to 8, the DD path name is, we have given DD path name as A. Case number definition 5, because it is a maximal chain of length greater than or equal to 1, because it's a sequence of statements, So let's consider another. So node number 12. So node number 12 we have named it as E, and if you see the case definition 3, this is very important. So it consisting of a single node with in degree in degree is greater than or equal to 2 or out degree is greater than or equal to 2, you just go to the 12th node. Where is 12th node? Here 12th node. So if you see in degree greater than or equal to 2 and out degree should be greater than or equal to 2. This since R, so this condition it falls under third case of definition. To derive the DD paths, so we should follow these 5 cases. Now we will see how are we arriving at the DD path graph for a given program flow graph for a triangle problem statement. Before that, let's again recall the definition of DD path, a classical definition which is given in the textbook called as policy jargon. A definition: given a program written in an imperative language, a DD path graph is the directed graph in which nodes are DD paths of its program and edges represents control flow between successor DD paths. It's a condensed graph. It's a condensed graph derived from program flow graph. The DD path graph is a form of condensation graph. In this condensation, two connected components are collapsed into individual nodes that corresponds to case 5 DD paths. Single node DD paths, case number 1 to 4, are required to assure that every statement is in exactly one DD path. So now there are two unique cases. One is case number 5, the other one is case number 1 to 4. So this is the table which is taken from the previous slide, which talks about the DD paths under which case we have taken the DD paths. So this is the condensation graph, which we call it as DD path graph for a triangle program. You can see that. See, this is first node number 5 to 8 has been condensed and made it as A. Similarly 9, similarly 10, similarly 11, similarly 12, 13, 14, 15, 16. 15 is here, 16 is here, 17 is here, 18 is here, 19 is here, 20 is here, 21 is here, 22 is here, 23 is here. We have condensed and we have renamed different paths. And we have executed from line number 1 to line number 23. This condensation graph we call it as DD path graph. In order to arrive this DD path graph, the 5 cases are very important. Case number 1, in degree is equal to 0. Case number 2, in degree is equal to what? Out degree is equal to 0. Then case number 3, in degree is greater than or equal to 2 or out degree is greater than or equal to 2. Case number 4, what is the case number 4? We want to ensure that case number 4, which talks about case number 4. Can you recall? The case number 4 is the single entry single exit case, and case number 5 we call it as maximal chain greater than or equal to 1. Now steps to build DD path graph. Number of program statements or set of statements or fragments. Draw a program flow graph. Divide the program graph into different DD paths using the 5 cases and build the DD path graph. So this is how we have built, and this is the DD path graph for the given triangle problem statement. Any doubts still here? I don't think so. I think because everything is clear. So everything is clear. Now with this, now let's move on to test coverage metrics. This is very important. Test coverage metrics. To what extent are we covered the test cases? Test coverage is defined as a metric in software testing that measures the amount of testing performed by a set of test cases. Test coverage metrics are a device to measure the extent to which a set of test cases covers a program. What test coverage exactly does? Finding the area of requirement not implemented by set of test cases helps to create additional test cases to increase coverage. is very important. Identifying a quantitative measure of test coverage, which is an indirect method for quality check. Identifying meaningless test cases that does not increase coverage. So because of this reason, test coverage makes very important, because we want to ensure that at least once we cover the line, the program statement, before we coming to the end of the statement. So this is where we cover the we completely see each and every statement while executing the program. So with this background, let's see how test coverage can be accomplished. Test coverage can be done by exercising the static review techniques like peer reviews, inspections, and walkthroughs, by transforming the ad hoc defects into executable test cases at code level. So our unit test level, our test coverage can be achieved by availing the automated code coverage or unit test coverage. Predominantly this is done by a developer. A functional test coverage can be done with the help of proper test management tool. But in order to do the test coverage, the structural test coverage are very important, because a lot of stakeholders will be involved, like business analyst will be there, like developers will be there, like testers will be there. So we want to ensure that we are covering all the requirements. All the requirements have been properly translated, and whether when program is written, whether all the line of statements, the program statements have been covered, tested thoroughly for every case before we deploy to the quality environment for the checking. Some of the benefits of the test coverage: it can assure the quality of the test. It can help identify what portions of the code were actually touched for the release or fixed. So this is very important, because before we release it, whether the code written by developer is pakka or not, it can help to determine the paths in your applications that were not tested, prevent defect leakage. So time, scope, and cost can be kept under control. So defect prevention at early stage of the project lifecycle is also one of the benefit. So it can determine all the decision points and paths used in the application, which allows you to increase test coverage. Gaps in requirements, test cases, and defects at the unit level and code level can be found in a easy way. Structural test coverage metric is one of the important the method to ensure that we are trying to cover all the cases. C0 is every statement whether we accord it or not. C1 every DD path with predicate outcome. C1P every predicate to each outcome. C2 C1 coverage plus loop coverage. CD is C1 coverage plus every dependent pair of DD paths. CMCC is multiple condition coverage. CJK is every program path that contains up to k repetitions of loop. CStat is statistically significant fraction of path. C infinity is all possible execution paths. So this is how we are going to consider all the metrics while doing structural testing. So predicate is equal to fragment segment. Predicate is always represented by every statement fragment. Most quality organizations now expect that the C1 metric as the minimum acceptable level of test coverage with respect to structural testing. Metric based testing. So again, there are different types of metric based testing which are available. Metric based testing are techniques that exercise source code in terms of structural testing coverage metrics. This coverage metrics requires that one should find a set of test cases such that when executed, every node of the program graph is traversed at least once. This is very important. When you are trying to do metric based testing, every node in the program graph is traversed at least once to check for the completeness. Now we have one statement and predicate testing which talks about C1 and C2, which I have discussed in the last slide. Then this is DD path. Again, this is also C1 metrics, which talks about the basic metrics. C1P, which talks about you traverse every edge of the DD path. And dependent pair. again we talked about C1P, again C1P. This is CMCC, multiple condition coverage. This is loop coverage. So in the loop coverage, there are different varieties of loops. One is nested loop, concatenated loops, nested loops, and knotted loops. So there is a difference between the concatenated loops and nested loops and knotted loops. So we just say this is predominantly used in the loop testing, because loops are very important in the in the control structures as well as in the programming aspects. This is a concatenated loop, where you can see that, see, one loop has been concatenated, one loop after the other loop is we call as concatenated loop. This is nested loop, where we started the loop. Inside this loop again there is one more loop which is already started. So this is knotted loop. We started the loop and we started again another loop, and we have ended the first started loop, then we are ending the loop which has started next. This kind of loops are called as knotted loops. So some of the few takeaways of the session are, we have seen the introduction to structural testing. Predominantly we have seen what is graph. Graph is a collection of vertex and edges, or nodes and edges. The graph can be cyclic or acyclic, directed or undirected. Importance of line numbers in structure. Line numbers are very important in doing structural testing. And program flow graph. And we have seen the control structures and notations used for program flow graph. And we have seen what is sequence, we have seen what is if then else, we have seen what is if then, we have seen loops like for and while, then we have seen case and etc. Then we have seen examples of program flow graph for a triangle problem statement, and we have seen DD paths and DD path graph with different cases. There are 5 cases where we have seen how are we converting the given program flow graph into DD path graph. Then we have seen the test coverage metrics starting from C naught till up to C infinity, and different technologies used in the structural testing. So metric based testing with different loops like concatenated loops, knotted loops, and nested loops. So this is all about the session 1 with the module number 1, with the module number 3, session 1. We hope we'll see you in the next session. I hope you people got the complete fundamentals which are needed to perform the structural testing. In the next class, we focus mainly into the basis path testing and data flow testing. So this session concepts are very important to explain the next upcoming session. So thank you very much.